Hi, this is Amy Johnson, and this is my final presentation for our class. I decided I wanted to present on cyclotomic polynomials. The goal of what I'm going to go over is how to factor and solve any cyclotomic polynomial over the rational numbers, and then determining the cyclotomic polynomial from the factorization. So what is a cyclotomic polynomial? According to Wikipedia, which of course is always accurate as we know, a simplified definition, I just copied and pasted the first part of it down here. In mathematics, more specifically in algebra, the nth cyclotomic polynomial for any positive integer n is the unique irreducible polynomial with integer coefficients that is a divisor of x to the n minus 1. So that means it just has to be able to divide evenly into x to the n minus 1, where n is an integer. So I decided to just start with an easier one. If we're going to look at x to the 8th minus 1, my first step is going to be to factor it. So they should be the ones that are prime divisors of this. So the first factoring, I know that that's a difference of squares, so that is x to the 4th minus 1, x to the 4th plus 1. I can factor that further by using the difference of squares on the x to the 4th minus 1. I'll go down to x squared minus 1, x squared plus 1, and then I'm going to leave the x to the 4th plus 1 for a moment. Then I can still do the x squared minus 1 as a difference of squares. And then I have to say I did go over to Mathematica just to make sure I wasn't missing anything, but this is as far reduced as it can possibly go. So we know we had all of those factors that were given there. So here's what I know. I know x to the 8th minus 1 has degree of 8. What I thought was really interesting when we studied this was all of my cyclotomic polynomials that are found in there are going to have to relate to the factors of that degree. So my factors of 8 are 1, 2, 4, and 8. So when I come in, those cyclotomic polynomials are only going to be able to be 1, 2, 4, or 8. And in this case, since when I factored it, I got 4 factors, it's going to be all 4 of those factors. So the cyclotomic polynomial of 1 is x minus 1 because its solution is 1. Cyclotomic of 2 is x plus 1 because negative 1 squared would get me to the positive 1. Cyclotomic 4 is x squared plus 1, and the cyclotomic polynomial of x to the 4th plus 1 would be 8. That's the number 8 one. I did go over and use Mathematica to double check it because I wanted to make sure I was doing it right. And I did learn, okay, so first I factored it. You can see that up there. But then here is the notation. If you want to just check what the cyclotomic polynomial 1 would be, you can type in this notation. It gives you x minus 1. Cyclotomic of 2, can type it in and it'll give you this one. So it was a nice quick way to check it. I did also learn, I think it's important to use the resources that are available to us. That's probably how most of us survive the course. If we go over, you can see I had to learn how to even pronounce it correctly, and I might not be doing it right. This was right in that Wikipedia site. It lists up to 30 all the cyclotomic polynomials going on down there. So if I wanted to check that way, I could. That is not the way I chose to do it. So I'm going to start this up again here. So start from current slide. There we are. All right, so then I thought, okay, I kind of understand that now. So let's just try another one. So I had x to the 18th minus 1. I decided to go bigger. Using difference of squares, I had x to the 9th minus 1. And then x to the 9th minus 1. Okay, I can go difference of squares again. So I have x to the 3rd minus 1, x to the 3rd plus 1. Then I know x to the 3rd minus 1 and x to the 3rd plus 1. Those are cubic binomials at this moment. So I just used my factoring of cubics to break down to x minus 1, x squared plus 1 plus x plus 1, and then x plus 1 times x squared minus x plus 1. And then I still have that x to the 9th plus 1. I opted to go over to, I used Mathematica to do my factoring on that, and it broke x to the 9th plus 1 on down, as you can see here, to the x to the 6th plus x to the 3rd minus 1, x to the 6th plus x to the 3rd plus 1. So I wanted to look at the factors of 18, because that is the degree of the original polynomial. So I had 1, 2, 3, 6, 9, and 18. All right, well, we've already done some of this. I know that this is cyclotomic for 1. This was cyclotomic for 2. All right, now this one right here should be 3. And this one was 6. If I recall correctly, this one is 9, this is 18. And I did go to Mathematica to double check this. There goes my chords. If I pull up the Mathematica file here, I did do the double checking. So the 9 is the positive one, the 18 is the negative one, the 6 is the one with the minus sign. You can see that going on there. So did we label them correctly? I'm thinking that I got the 9 and the 18 possibly mixed around. I do. Nope. I think I have them right. I had a momentary timeout there. I had a typo actually up on my screen. This is supposed to be the minus sign. So now we have everything correct. When Mathematica does it, they, for some reason, factor in ascending order. If I bring this one up here, you'll notice all the powers go ascending. And as mathematicians, we're used to going with descending powers, and I just got turned around and wrote it wrong. But it has now been corrected. So I think it's interesting that all those cyclotomic polynomials, there are going to be the factors of the original polynomial, or the degree of the original polynomial. So then I thought, okay, well, what if I choose one that isn't even? If I go with one that is odd in degree. Factored x to the 27th minus 1 on down, and I'm not even in display mode for you here. But that goes and factors down to x minus 1, x squared plus 1, x to the 6th. And then my factors of 27 are 1, 3, 9, and 27. Well, we've already done 3 of those. So the only new one is the 27. This is the first. This is the second. This is the 9th, not second, that's the 3rd, 9th, and this is the 27th. And there we have our cyclotomic polynomials. I was going to move in and show you how the roots applied and how we can get conjugates of things and go on out to group fields, but my time is up. And so we'll call that good. Thank you.